Alrighty. So vector A has a magnitude of 4 units and vector B a magnitude of 6. The angle between them is 45. What is A plus B? So I've sort of begun drawing out what this could potentially look like between vectors A and B. Vectors shown here. And let me just add in the angle 45 degrees between them to show what they're talking about. So what are they actually talking about? Well, the way to think about this in vector addition is you set up the vectors tip to tail, and that's how you can add them up. So what does that mean is you would imagine moving over this vector like this. So now A is over here, and so vector AB is actually going to be the vector that connects A to B, which I'll draw on here. So this would be vector AB, which I'll label on. All right, so how do we find the magnitude of this vector? Well, as you can see here, vector A plus B. So as you can see here, the magnitude of this vector is equal to the components, to the sum of the components of each individual vector A and B. So the way I've drawn this out now is if we imagine our axes to be the vertical and horizontal lines, X and Y as we're used to, as you can see, the vector B lies entirely on the horizontal, and vector A has components that are both on the horizontal and on the vertical. That's not what I want to do. So move that 45 degrees to show that that is supposed to be here relative to the horizontal. So let's find out the components of AB. And the way you do this is to sum up those components of individual vectors A and B. And let's start with component number X. Or let's start with the X components, the sum of the X components. So if we look at our graph, again, vector B is completely horizontal and lies along the X-axis shown here. So the component of B that is on the X-axis is the entirety of B. Meanwhile, let's look at A. So the component of A can be decomposed into the following axes. Its X component, shown over here along the horizontal, and its Y component, shown vertically, like this. If we remember our trigonometry, then we know that the X component of vector A is the cosine of 45 multiplied by magnitude A. So let's write that out here. It would have been, the X component for that is A cosine of 45. All right, so those are the two components in the X direction. Now let's find out the ones in the Y. And we'll write that over here. And let me just make it abundantly clear. What we're doing is labeling the X components and the Y components. All right, so as we said before, B is entirely horizontal. Not a single component of B is in the Y direction. So that is going to be 0, which I will write out. And like before, there's only a small component, there's only a component of the A vector that is in the Y direction. That's going to be the magnitude of A times the sine of 45 degrees, which I'm going to write out here. A sine of 45. Perfect. So now that we have our components, we know that in vector direction, the magnitude, so these are going to be the two components of the vector. So now we have to think about how we're going to get the magnitude of B. Well, let's draw it out as a triangle. I'm going to redraw it out. So we know that, actually, let's make this perfect. So this vector, A plus B, I'm drawing out over here, has the looks like this, a triangle, and has the following components. The X component is B plus the A cosine 45, and the Y component is A sine 45. So how do you find the magnitude of this vector? Well, just like you find the magnitude of any triangle, a Pythagorean theorem. So let's see if I can write that out down here or not. If anything, okay, I'll just make a new page. All right. So vector A plus B in magnitude is equal to A cosine of 45 plus B squared plus a sine of 45, and all of that is also squared. Then you would take the square root of this, and I will let you do the math. Just plug in the magnitudes for A and B. I think it was A is equal to 6 and B is equal to 4, and you should have your answer. Good luck.